In this video, we're going to go through some more examples on using rules of inference in valid arguments or showing valid arguments. Okay, so this example, using the rules of inference, construct a valid argument to show that John Smith has two legs and that we want to show it's a consequence of these premises. Every man has two legs and John Smith is a man. Okay, so let's go ahead and start with writing the information into variable and propositional form. Okay, so for man, we'll let m of x represent that x is a man. Then we'll let L of x represent x has two legs. And those are really the two propositions here. We have a specific individual, John Smith, that we'll refer to. Okay. So here we go. Let's go ahead and write it out. So the first premise, I'm not going to put steps in reason. I'm just going to do the stepping through. So the first premise, or first thing, is we're going to list the first premise. So here's how we say the first premise. For all x, if you are a man, then you have two legs. So that's the first premise. Now, the second thing is that we are told that John Smith, and I'm just going to call him John, is a man. So you can always start by listing your premises first if you want, and then kind of do your arguments. You don't have to go through the arguments as you're listing the premises. Okay, so now from number one, I can say specifically that John is implying two legs. That is using universal instantiation from the first premise. So you might recall those four things that we talked about at the end of the last video. Universal instantiation is when you take the generalized premise and you apply it to a specific individual. So in this case, the individual is John. Okay, so if John is a man, then John has two legs. And we are establishing John as a man from one of our premises. Therefore, we can conclude that John has two legs. And that follows from modus ponens on numbers 2 and 3. Oops. 2 and 3. Sorry, squeezing that in. Okay, so that's how we'd set that up and how we would use the rules of inference to kind of help us argue this. Okay, when we're talking about a specific person. Let's use the rules of inference to construct a valid argument. Someone who has passed the first exam has not read the book. Follows from the premises. A student in this class has not read the book. Everyone in this class passed the first exam. Okay, so we need to get some propositions going here, and then we'll label these using those propositions. So let's see, every student in this class has not read the book. Okay, so let's let C of X denote that X is in the class. And B of X will represent X has read the book. And when I want to say not, I'll use the negation symbol. Okay. And then let's use P of X to refer to X has passed the exam. Okay, so let's use those labels to write these premises. Okay, so the first premise, a student in this class has not read a book. Okay, so that means there exists an X where they are in the class and haven't read the book. That's how we'd say that. The next one says every student in the class passed the first exam. So for all X, if they're in the class, that means they passed the first exam. So we'll use the if-then format. So our conclusion is there exists someone who passed the exam and not read the book. So that's the conclusion we want from these two premises. Okay, so let's start up our argument here. So I'm gonna, again, I'll forego writing steps versus reason, okay? And I'll just go ahead and do the first premise, which is there exists an X that is in the class and not read the book. Okay, that's the first premise. Second, okay, I could go ahead and state the second premise if I wanted to. There would be nothing wrong with that. In fact, I will. I'm just going to show you that you can do that. It doesn't matter if you do it right off the bat or later on, but I'm going to just show you that I can do it. I could just state the two premises right off the bat. Now they're down and I can just refer to them based on what I want to argue. Okay, so for there exists, we have the EI, which is the, oh, wow, I forgot what it's called. Sorry, I'm going to refer back. Existential instantiation, okay, EI. And again, you may want to refer to your notes back on these. That's when you start with a generalized there exists statement, and then we say it specifically for someone, okay? So let's call that someone A. We're going to use the little letter A that they did in one of those problems. So we're going to, from part number 1, I'm going to say C of A and not B of A. That is using existential instantiation from number 1. Okay. I could probably do that with number 2 as well, but I believe number 2 wouldn't be existential inferentiation. It would be universal inferentiation because it's the for all versus the there exists. Okay. But I won't do that yet. I'm going to go ahead and work with this first. So here we go. What we're trying to say then is, or I should say what we're trying to get to is we'd like to pair up P of X. Oh, wow. That. Let me undo what I just did there. Boop. Okay. It didn't switch to the highlighter. P of X. We want to pair up P of X and not B of X. That's what we want to do. Our goal is to pair those two things up. If you look back at our arguments, ways of pairing things up, we can pair things up using conjecture. In fact, here, I'm going to scroll back. I know that's going to be a little bit annoying. Conjunction is when we put two things together in an and statement. And that's what we want. We want two things together in an and statement. All right. So let's go ahead and do that. Oops, sorry, too far, Allison. Okay. So what I want to do then is I would like to break up the C of A and the not B of A. And I want to get not B of A. I'd like that right now because I need that statement to put into my final statement. So that's what I'm going to do. I'm going to go ahead and from this, I'm going to conclude not B of A, and that's simplification. That's when we start with an and statement and we grab one of them only. Simplification. Okay. Now I'm going to take number 2 here, the premise, second premise, and I'm going to do it for a specific person again. So this time C of A, that's a C. C of A implies P of A. So I went from something general to something specific. That's U of I from number 1. So it's the universal instantiation because it's the for all statement. All right. Then because okay. So in order to get to P of A as its own statement, because that's what I need P of A by itself. So I could put it together with not B of A. Okay, I want to put them together. Okay, so I need C of A now. And I can get C of A from number 3, just like I got B of A. I can use simplification. So I can have C of A, and that's from simplification from number 3. Now, pairing up 5 and 6, that's modus ponens. Oh, I'm running out of space. It's modus ponens from 5 and 6. I'm going to try to squeeze it into the next page. I'm sorry. My writing is just too big. Okay, so number 8 then. Now I can pair up the two things I was after, P of A and B of A, using conjunction. I think I said that right. Conjunction, right? Sorry, I'm going to scroll back. Conjunction. All right, cool. I said it right. So P of A and not B of A. That's using conjunction from 4 and 7. Okay, now we're almost done because the last statement we are taking for a specific person and quote unquote generalizing it to be more general and saying that there exists someone. So that's using existential generalization, e.g. So I can write this as, since it happens for a specific person, I can say it exists for someone. I happen to know who the someone is, but that's okay. Oops, I can do this. B of X. And that's existential generalization on number 8, or from number 8. And there we go. Whew, that was a lot of work. A lot of work. Okay, I have one more example. We're going to come back to the Socrates example. After all that hard work, this one isn't too bad. All right, so returning to this example, here's what we have. And they were nice enough to actually give us all the labels in the argument, so we can use those. We're going to start with the premises. For all X, man of X imply, if they're man, they are mortal. That's the premise. I'm going to go ahead and state the second premise. Socrates is a man. That's our second premise. Now, I can generalize number 1. I'm sorry. I can make number 1 specific to one individual. Since it's true for all of them, I can say it's true for one person in particular, Socrates. If Socrates is a man, Socrates is mortal. That comes from universal instantiation on number 1. So taking a for all statement and applying it to a specific person. All right. Now, pairing up numbers 2 and 3, that's modus ponens. So I can conclude that Socrates is in fact immortal using modus ponens on 2 and 3. Sorry for my very big writing, but that's how we would do that argument. Now, there is one more thing they point out in the book, and I went ahead and put it in here. Universal modus ponens. We can start with a for all statement and then talk about a specific person and jump into saying that the conclusion applies to the specific person from the for all statement. We don't have to go through the step of using universal instantiation for it. So modus ponens is pretty powerful, and universal modus ponens is the powerful statement of it works for all of them. So why go through this particular extra step, step 3 in particular? I don't know why it's not updating when I've asked it to. Oh, okay. Now I'm really being annoying. Sorry. Home. There we go. Undo. Okay. So the third statement here is the one that we kind of wanted to avoid if we could. It's just annoying. It feels like we should be able to conclude number 4 just from numbers 1 and 2. And that's what this is, universal modus ponens. And that's it for this section.